Hello everyone, I hope you're doing well today. Today we're going to learn how to graph a quadratic function in intercept or factored form. Before we start learning how to graph them though, let's look at some key features of the graph of a quadratic function. A quadratic function creates a U-shaped graph called a parabola. This particular parabola is concave up, meaning that it opens upwards and looks like a U. Parabolas can also be concave down and open facing downwards, where they look like an upside down U. The highest or lowest point on the parabola is called the vertex. The vertex lies on a special line of the parabola. It's called the axis of symmetry. The axis of symmetry cuts the parabola in half into two symmetrical pieces. Remember, to be symmetrical, it means that it's the same on both sides. Some other points of interest on a parabola are the y-intercept, where the parabola crosses the y-axis, and very important and key points for our lesson today, the x-intercepts or solutions, which are the points where the graph crosses the x-axis. Please take a moment to pause this video and record this picture and definitions in your notes. Now that we know what a quadratic function looks like, let's delve a little deeper into intercept or factored form. Intercept or factored form is y equals a times the quantity of x minus p times the quantity of x minus q. The reason why this is called intercept form is because p and q are the x-intercepts or the solutions for the function. Now let's take a look at the example. Y equals 3 times the quantity of x minus 4 times the quantity of x plus 2. In order to graph this, we're going to follow 5 steps. Step 1 is going to be to find our x-intercepts. Remember, the x-intercepts are where the function crosses the x-axis. Any point that lies on the x-axis has a y value of 0. So our first step is going to be to set our equation equal to 0 and solve. So I have 0 equals 3 times the quantity of x minus 4 times the quantity of x plus 2. Now that I have an equation, I can solve it using the zero product property. When we apply the zero product property, we set each factor or each set of parentheses equal to 0 and solve for x. So I have x minus 4 is equal to 0 and x plus 2 is equal to 0. To solve my first equation for x, I add 4 and get x equals 4. To solve the second equation for x, I would subtract 2 and get x equals negative 2. So our two x-intercepts are 4 and negative 2. Our second step is to find and draw the axis of symmetry. The axis of symmetry lies directly in between the two x-intercepts. To find the number that lies directly in between 4 and negative 2, I need to find the average of those two numbers. To find the average of any two numbers, add them together and divide by 2. So my axis of symmetry is the line x equals 4 plus negative 2 divided by 2. 4 plus negative 2 is 2, and 2 divided by 2 is 1. So my axis of symmetry is the line x equals 1. Let's take a moment to draw in our x-intercepts and our axis of symmetry before continuing on to the next step. Our third step is to find the vertex. Now the vertex is a point that lies on the axis of symmetry. So to find our vertex, I need to take my function and substitute in 1 for x and solve for y, and that will give me the point for my vertex. So I have y equals 3 times 1 minus 4 times 1 plus 2. So I have 3 times negative 3 times 3. 3 times negative 3 is negative 9, times 3 is negative 27. So my vertex is the point 1, negative 27. Now the point 1, negative 27 is not going to fit on this particular graph. So let's adjust our scale. Instead of going by 1 on each of the y values, we'll go by, let's say, 3 because 3 is a factor of 27. So my vertex would be the point down here, 1, negative 27. My next step is to find other points that lie on both sides of the vertex. And then my fifth and final step would be to plot all the points and connect them with a smooth curve. So let's find some other points that lie on our parabola. So let's find the y-intercept. To find the y-intercept, we plug in 0 for x. If I plug in 0 for x, I get y equals 3 times 0 minus 4 times 0 plus 2. So I'd get 3 times negative 4 times 2. 3 times negative 4 is negative 12, times 2 is negative 24. So I also know I have the point 0, negative 24 for my y-intercept. Now since my parabola is symmetrical, or the same on both sides, I know that I also have a point directly across on the other side of the axis of symmetry at 2, negative 24. Now that I have several points, the only thing left to do is to connect them all to create my U-shaped graph or parabola. Please take a moment to pause this video and record this example in your notes. Now let's try taking a look at another example. This one is a little bit different because we only see one factor here that has been squared. The equation is y equals the quantity of x plus 3 squared. What this means is that I will only have one x-intercept. Whenever there is only one x-intercept, that x-intercept is also the vertex of the function. So let's start off by doing the same steps to start with. I'm going to take my equation and set it equal to 0 so that I can find my x-intercepts. Once I have my equation set equal to 0, I apply my zero product property by setting each factor or set of parentheses equal to 0 and solving. To solve the equation x plus 3 equals 0, you would subtract 3 and get x equals negative 3. So that means that the point negative 3, 0 is both our solution, x-intercept, and vertex of the equation. Well, since I know that the vertex lies on the axis of symmetry, I don't have to go any further to find my axis of symmetry. I can just draw the line down through it, and I know that my axis of symmetry is the line x equals negative 3. Now I need to find other points on both sides of my axis of symmetry in order to graph my parabola. One of the easiest points to find is always going to be the y-intercept. So let's plug in 0 for x to find the y-intercept. So I have y equals 0 plus 3 squared. 0 plus 3 is 3, and 3 squared is 9. So that means that I have the point 0, 9. Now I know that my parabola is symmetrical, or the same on both sides of the axis of symmetry. If I count from my axis of symmetry over to the point I just drew, it's 1, 2, 3 units away to the right-hand side, which means if I go 3 units to the left of the axis of symmetry, I also have the point negative 6, 9. Now that I have at least 3 points, I can draw my parabola. So if I connect my points, I've got my U-shaped graph, and at this point we have graphed the function y equals the quantity of x plus 3 squared. Please take a moment to pause this video, record the example in your notes, as well as any questions that you may have. Take care, be well, stay safe, and I'll see you soon in our Zoom meeting.